Okay, so the opposite faces of a standard 6-sided die add up to 7. Two identical standard 6-sided dice are placed side by side as shown. What is the sum of the numbers of the dots of the two faces that touch each other? So first, what we know is that the opposite sides of the die always add up to 7. So we know that the bottom of this one is going to be a 2 because there's a 5 up there. The back of this one will be a 1, the side we can't see, because that's a 6 right there. And then we know that the one on the middle, which is what we're trying to find, is going to be a 4 because it's opposite of 3. So we know we're going to be adding 4 and another number. Next, what we have to do is we have to basically rotate the first cube in our mind, because we know that the only thing they have in common are the 3 on each of them. So if we rotate the first cube upward so that the 3 is on top, we will end up with something like this, where there is a 3 going across, and then 6 going down. So now what we know is that when we have this 3 like this, oh wait, nope, I messed that up. Let's redo this. Okay. So when we rotate this 3 up to the top, we will have the dots going that way, from the bottom left to the top right. We will have the 6 going down that way. But now over here, we notice that this 3 is similar, except it's going the other way. It is going this way across. So we have to rotate it one more time. So that would mean that this 6 would go to the back of the cube. So that would mean this side back here is going to be a 6, which means that the one opposite is the 1. So the 1 is on the inside, so we have the 4 plus the 1, and that gives us the 5. Okay, problem number 20. How many sets of 2 or 3 distinct positive integers have a sum of 8? So first I'm going to start with the sets of 2. And I'll go from largest to smallest for the first number. So we could start with 7 and 1, 6 and 2, and then 5 and 3. We can't do 4 and 4 because 4 is not distinct from 4. And 3 and 5 is just the same as 5 and 3, and you don't want to count those twice. So these are the only 3 2 number sets. So now we move on to the ones with 3 sets. So I am going to start with the largest first digit I can, which would be what would that be? Oh, it would be 5. Because if I have 6, I would have 6, 1, 1, but 1 is not distinct from 1. So I could have 5, 2, 1. And next, if I have 4, I could have 4, 3, 1. But if I have 3, then I would have to have 3, 3, and 2. Or, yeah, just 3, 3, and 2. Or something else that I've already used. So these are the only 2 groups of 3 that add up to 8 that are distinct. So that gives you a total of 5 sets. Okay, next, number 21. No, it's... Okay, has it started? Okay. So now we're back from Jay's commercial break, and we are moving on to number 21. If a, b, and c are integers such that a plus b over 2 equals 3, b plus c over 2 equals 4, and a plus c over 2 equals 5, what is the value of a plus b plus c? So what I first did is I rewrote all of the equations. A plus... No, that's not what I want. A plus b over 2 equals 3. But then what I did is I multiplied both sides by 2. So that gives me a plus b equals 6. I did that for b plus c over 2 equals 4 also. And that gave me b plus c equals 8. And then I did that for a plus c also to get a plus c equals 10. And next what I did is I added up all of the equations. Oops. I messed up right there. That one should be a 6. So a plus b equals 6 and b plus c equals 8. So next I added all the equations and I get 2a plus 2b plus 2c equals, that would be 24, because you add the 6, the 8, and the 10. And then you can just divide everything by 2, and it'll cancel out all those 2's, and 24 over 2 is 12. So then you get a plus b plus c equals 12, and 12 is your answer. Okay, moving on. I'm just going to clear this. So the mean of a set of 5 numbers is 3k. When a 6th number is added to the set, the mean increases by k. What is the ratio of the 6th number to the sum of the first 5 numbers? Express your answer as the common fraction. Okay, so first what I did is I know that the mean of the first 5 numbers is 3k. So that would mean let's just say a plus b plus c plus d plus e all over 5 equals 3k, and a plus b plus c plus d plus e, those are the first 5 numbers. You don't really have to find every individual one, but then you can multiply both sides of the equation by 5, and you would get those first 5 numbers. I'll just call that f. So f is the first 5 numbers equals 15k. So once you know that those 5 add up to 15k, you can find that f plus the new number, so I'll call that x, divided by 6, because now you'll have 6 numbers when you find the average. That will equal 4k, because you're increasing the average by 1. So next you can multiply both sides by 6, and you would get the sum of the first 5 numbers plus the new number equals 24k. And you're already given that the first, we figured out that the first 5 numbers is 15k. So you can just replace f with 15k. So then you subtract 15k from both sides, and you get x equals 9k. So now what you're trying to do is find the ratio of the 6th number to the sum of the first 5 numbers. So you would have 9k over 15k, and that gives you an answer of 3/5, because the k cancels out, and then you simplify it. Okay, next, number 23. The large rectangle shown here is composed of 4 squares. If the area of the larger rectangle is 240 inches squared, what is its perimeter? So I started by calling the side length of the smallest square x. So we know that this is also x, and then this is the same square. So you could have another x, x. And then I see that this is 2x. So this square is 2x by 2x. Next I found that this length here is 2x. This one below it is x. So that means this square has a side length of 3x. So now we know that this whole length, the height, is 3x, and then the width is 5x. So to find the area, you would just multiply 3x by 5x, so 3x times 5x equals 15x squared. So you have 15x squared is equal to 240. So you could divide both sides by 15 to try to isolate x. And when you did that, you would get, what would you get? I'm going to bring out the calculator. Or no, this is spread around, never mind. Okay, so you could divide both by 5, and you get 3 there. Divide that by 5, and that would give you a 48. I did that right, Jay, didn't I? 240 over 15 is 48 thirds. Yes, right. Then you could divide that again, and you would get, it is 16. Okay. Sorry that took so long. And then, so you would get x squared equals 16. you square root both sides, and you get x equals 4. So now it's asking for the perimeter. So you know that the height is 3x on both sides. So both of the heights added will give you a total of 6x, and then the two widths are each 5x, so that's another 10x. So you get 10x plus 6x is 16x. So 16x is the perimeter, x is 4. 16 times 4 equals 64, and that is your answer, 64 inches. Okay, last problem, number 24. What is the least positive integer n such that n prime is divisible by 1000? So first what I did is I broke it down and found the prime factorization of 1000. So I just took out 5 first, then that gives you 200. Divide 200 by another 5, that would give you 40. Divide 40 by another 5, that would give you 8. And then you can divide the 8 into 3 2's. So now you find the least positive integer n such that n factorial is divisible by 1000. So you know that each factorial, so you need to have all of these factors. You need to have 5 to the third times 2 to the third in n factorial. So let's just start listing out factorial. So 1 factorial is just 1, times 2 would give you 2 factorial, times 3 would give you 3 factorial, times 4 would give you 4 factorial, times 5 would give you 5 factorial. Let me just get this out of the way. Times 6 would give you 6 factorial, times 7 would give you 7, times 8, ... And you know you have to have the 5 to the third and the 2 to the third included. So you know that 2, by the time you get to 4, the 2 has already come up 3 times, because there's a 2 there, a 2 there, and a 2 there. So now you're just trying to find the 5 to the third. So you know that as soon as you have 5 to the third, that factorial will be your answer. So you have 1 5 here, and you need 2 more. So you can go to times 9, and then times 10. 10 is 5 times 2, so that's another 5. And then you know that your next 5 will be at 15, because you're just counting by 5s, basically. So at 15 factorial, you will have 5 to the third and 2 to the third. So, and those are the factors of 1000, and you need all of the factors of 1000. So 15 is your answer.